Welcome to Brain Vision.
So here in this problem we are given this car and the weight of the empty car we are given to be as 54,600 pound. Now this car is being loaded with a call of weight 180,000 pound. Now the car have two openings here, as you can see here, and the car dumps coal at the rate of 20,000 pound per second. Now we have to calculate this force P at the instant when half of the coil is being dumped, and the acceleration of the car should be 0.15 feet per second square. And we are also given with frictional resistance F, which is equals to 4 pound per ton of the total weight remaining, and let the total weight remaining be WR. So this is WR. Now to solve this problem we'll be using the variable mass approach. So we'll be using variable mass approach, and we're going to first make the free body diagram of the car. So this is our free body diagram and this one is x direction. So we can use this approach and we can write that sigma fx is equals to m dot u plus m v dot, and this v dot is nothing but the acceleration of the car. Now this mass is the mass when the is the total mass of the system when half of the coal has been dumped, and this is the friction force. Now let us first calculate the friction force when half of the mass of the coal has been dumped. So friction force F would be equals to, this would become 4, let me change the units, so divide by 2000 times the weight, remaining weight is 54,600 weight, it will remain as it is. Now we have to take half of this value because half of the coal has been dumped, so this would be 90,000 pounds. So we'll get this force to be 289 pound. Now in x direction we have two forces, so we can write that sigma fx will be equals to P minus F equals to, now m dot u, here u is the relative velocity of the coil with respect to the car in the x direction, and there is no relative velocity in the x direction because the coil is moving like this, it is dumped in this direction, so this u would be 0, so this whole term would be 0, and this mass is the remaining mass, so it would be 54,600 plus half of this number, that is 90,000, divide by 32.2 to balance the unit, times this v dot means the acceleration, which we have 0.15, and if we have calculated as 289, so we can plug it here. This is P minus F is 289. So we can solve it for P, and the value of P comes out to be as nearly 963 pound. So this is the force required that was asked in the question. I hope you have understood the problem. Thank you.